Hi everybody, it's me Boyan and I wanted to show you RAG Academy, a mini project that I have been working on for a couple of weeks now. So what is RAG? RAG is Retrieval-Augmented Generation, like it's an acronym, but in essence it is an AI framework that enhances large language models, LLMs, and it connects them to some sort of external database. If you want to build a chatbot, you are probably going to use RAG at this moment at least. So I started working on this project for my own needs. So I wanted to learn how to actually create RAG, how does RAG work in the back end, so that I can understand what is happening inside of these AI-powered systems. So this RAG Academy, in essence, you can look at it as some sort of sandbox. It's a learning sandbox where you can interact with this technology that powers the AI tools that are based on RAG. I'm going to show you how it works. We will go step by step through each of the RAG process. And we always start with some sort of document because we need to connect our app with some external document. In the app itself, we can upload a document, we can paste something, but I will use these predefined documents for testing purposes. So first, we are going to start with this little paragraph of the solar system. And the first step is actually to chunk it down into smaller pieces. Why? I mean, same thing as in learning. You would chunk something into smaller, manageable, digestible pieces so that the learner can learn in a more efficient way. But it is the same thing for AI, because AI actually works the best with these smaller, bite-sized inputs, chunks. Chunking, in essence, helps AI focus, match, and retrieve in a better way, more efficiently. So in RAG Academy, we have a couple of chunking strategies. So we can use the fixed size. So there is a chunk size of 50. So it's going to take 50 words. Let's put there 20, let's see. And there's going to be an overlap of 5 words. So now it is going to, if I generate the chunks, by the way, through each step, you get these little pop-ups that are going to explain what is actually happening. So now we have first chunk with 20 words, and there is an overlap of 50 words in the chunk 2. So now we have quite a lot of chunks, 9 chunks. So fixed size, not ideal. We can split it by sentence, respecting the sentence boundaries. There is this recursive character splitter, which is the most efficient way, and it actually tries to preserve the full ideas. It's going to use the punctuation, grammatical rules, and so on, paragraphs, and so on, in order to create the chunks that, from the standpoint of the strategy, seems it encompasses the most meaning and the most value that we can find. And we also have the custom one, where we can split it by a specific symbol or combination of symbols or words, and we also can define the overlapping characters or words. So that's the first step. So we have created our chunks. The next step in the RAG process is actually going to be for us to create embedding. Embedding, in short, is the way to turn these chunks, the text from the chunks, into numbers, specifically into vectors, which is just, in this case, a list of numbers. Think about them as like giving some sort of fingerprint of meaning to the chunk that we have. I'm going to generate the embeddings using 2 models, OpenAI's and Cohere. These models are actually small models, and they are really specialized into converting text into numbers. So that's their main value that they bring. But it is really important because depending on how you actually create the embeddings and create this whole matrix of meaning, your retrieval process is going to be more or less efficient. As you can see, we have over 1,500 here, a little bit above 1,000 dimensions. And each chunk is going to be 1 point into this enormous 1,000 dimensional space. So it's almost impossible to visualize. So if I just click generate embeddings, I'm going to use both models. And while it's generating, I mean, what are these dimensions? Well, actually, no one knows, at least based on what I figured out and what I tried to find. No one fully knows, but what we know is that now when we have all these numbers, AI can compare the meaning of these 2 chunks, even though they use different words. How? By using math. An interesting concept. So now we can check our embeddings. So if I go to the embedding visualization and I click on chunk 1, we can see that there are similarities between chunks. So let's compare, for example, OpenAI and Cohere. If I click on Cohere, we can see that all chunks are similar, but the values, the similarity is different. And if I go, okay, so this is an interesting example about how using different models can create different meaning and different connections. So if I take a chunk 2, you can see that the most similar chunk is chunk 3 if we look at OpenAI. But if you look at Cohere, it's actually chunk 6. So why is that? We don't know. But depending on how you might actually fine-tune this little embedding model, you will get something that is more or less aligned with what is your specific need. And similarity closer to 1, high similarity, lower similarity. And then when we go into the next step, and that is going to be our query. What is the smallest planet? So now what will happen when I click search? AI will turn my question into a vector. It's going to put it into something that's called a vector database, and it will find the one that is closest to its meaning. So this is something that is called a semantic search. So in our case, let's see. What is the smallest planet? If we look at OpenAI results, it is going to say that the most similar chunk is chunk 3, which is our home, support Mars, Jupiter is largest, while Mercury is smallest. So it did a good thing. And Cohere actually did chunk 4, but don't forget that we used an overlap. So in essence, it actually used the overlap of the chunk 3, which is the second most similar one in this case. And here we can see that OpenAI prioritized chunk 3 and Cohere prioritized chunk 4. And now imagine you adding whatever you want, different documents and so on, and you want to understand how actually the system and how actually each of the embedding models work with the text that you give it, with your chunking strategy, in order for you to see what is going to help you create the most efficient system. If our embeddings and if our chunking strategy is weak, we might pull a chunk that says something incorrect. I mean, this is really small sample, but imagine that you have a book of 1,000 pages or something. It's going to be much bigger database, and we are using this just for showcase. And then in the end, we have a generate phase. So now when we have our question or query that is also being vectorized or embedded, and if we have our chunks and our chunks that are prioritized, so in this case, we have chunk 3 and chunk 4, when we click generate answer, so what is going to happen is we are going to send these two chunks and our original question to large language model, in this case ChatGPT 4o. It is going to generate. So we had a retrieval, we had augmentation. So we retrieved the chunks, we augmented it with a question, and now we are generating an answer based on those two things. As expected, we are going to get an answer that Mercury is the smallest planet. And that is our full loop. So we retrieved the right content and we generated a grounded answer. So, and that's it for this demo. RAG Academy is a space for us to see how AI thinks, how it works, so that we build better tools, ask smarter questions, and guide learners with confidence. So that's been it. I might do some additional deep dives just for you to see how chunking strategy affects the quality of the answer, because there is this whole notion that a lot of people are not aware of pre-processing, like preparing your data to actually for it to actually be easily understandable to the AI systems. If you want to try it out, send me a message. This uses really API, so like if you reach out to me and I ask you to test it out, I'm going to ask you for feedback. So be aware of that. If you try to break it, question it, play with it, because in essence, understanding this engine will make you a better driver. Thank you for watching, and see you in some other video.